Every time I go out, I need to check the weather app on my phone to see what temperature it is, so I can decide like what clothes I should wear, and also check if it's going to rain. So to simplify that process, I made myself a weather display. So this is, you can't really see it. Alright. So I laser cut this, and I drew this thing on Adobe Illustrator and laser cut it. It's two pieces. It's like the stand and then like the panel. Yeah. It kind of stands on the wire. And like this connection is not super stable because I just plugged it in. I didn't solder it. So this is a bicolor LED. It's green and red, and right now it's green. It looks white on the video, but to like my human eye, it's very green. And this is a segmented, what's it called? Like 4-digit 7-segment display, yeah. And it came, like I bought the display, the LED light, and the backpack. So basically it's like the LED driver, and like I soldered the LED display and the backpack together. And this uses Stemma QT. And I glued the two lights on the panel. This is a battery pack, so like I can move this around. I don't need to connect it to a computer. And this is a Raspberry Pi Pico W. It connects to Wi-Fi, and I make API calls to the Open Weather API. I put like my personal information in the settings file, so that like I can post this code online without showing everyone my password. So this is the two URLs. This is for the current weather. This is the 3-hour forecast. It's both of them are free. I scheduled this to like update the temperature every 10 minutes and update like the rain forecast every 30 minutes. And for every 10 seconds, like I alternate between Fahrenheit and Celsius. So the green light, so the forecast is for like the next 3 to 6 hours. So if it's going to rain in the next 3 to 6 hours, it's going to be red, and if it's not going to be raining, this will show green. So I make the API call to that URL, and then like parse the JSON information to get the temperature. And the temperature is a global variable because I needed to, like, I scheduled them separately, so it's not like one inside the other. So I need the temperature. So this function is for how to display the temperature on the segmented LED lights. So this is how, like, it's alternating between Celsius and Fahrenheit. So it takes in the temperature. The temperature is by default the Kelvin units, which is like the first time I come across Kelvin temperature. Weird, computers are weird. So it takes in that information. It's an empty string here, but it doesn't matter because, like, I would call get temperature first, so it's going to be whatever like it gets from the internet. Right, and then it converts it to Celsius and Fahrenheit, and it like turn off the display first and then turn it back on, because I find out, like, if I don't turn it fully off, it's going to, like, append the new string to the old one. So it's going to be like C10C, which is really weird. Yeah, so I left one digit here to show the negative temperature if, like, during the winter. It's going to print out connected to Wi-Fi, and then this to URL, so that, like, I can click on the URL. And it's actually necessary because I kept getting into the like the paid version, and then this API call would return an error, and it's actually because, like, the API key was invalid. I think Open Weather API made that on purpose so that people would accidentally click into the paid version and then pay. Right, and then this part, it's like the API call, which is the same except I used a different URL. And yeah, this is complicated. It's layers of lists and dictionary, and it's kind of confusing. When do I need, like, an index? When do I need a key? Oh yeah, this one is printing the weather. This one is printing the temperature. So the weather could be, like, clear, which it is clear right now, and it has, like, lots of other options, but I only care about if it's going to rain. So in the middle is a shared cathode between the green LED and the red LED. These two are anodes, like, separately, and I need to connect a 47 ohm resistor to each of the anodes. So the green one goes here, and then to GP12, and then the red one goes to GP7, I think. So I made this because I want a weather display, but also because I want to kind of incorporate what we learned in class, like after I designed the last project. So which is we learned about like how to turn on LED and pick resistors, and I did use the online ohm resistor calculator. Yeah. And also making API calls, which is the first time I do it. It's really cool.